Hi, Gil from Testing Gil here. If you're like me, you use TDD. You write tests first. But if you're not, let's say you just written something pretty complex. You're pretty proud of it. And you checked it and you debugged it. Everything's cool. But now you're staring at the screen and you're thinking, how on earth am I going to test it? You know, or you think you know, that the happy paths work. What about the other paths? Are there any edge cases hiding in the shadows? Okay, time out. If you've seen my other videos, you know there are no edge cases. There are really cases that you didn't think about. Those definitely hide in the shadows. You need help. Well, luckily, you have an AI assistant in residence. Let's ask it to put a spotlight on those nasty cases. Now, we're in developer mode, right? We've written the code and the AI assistant is living with us in the IDE. It knows the code, maybe even more than us. Okay, here's our code. This is a logic class for solving the Towers of Hanoi puzzle. The Towers of Hanoi is a classic puzzle. It has towers with disks stacked on them, all of them from the bottom to the top, from the largest to the smallest, on one tower. The goal is to move all the disks to another tower, but you can only move one disk at a time, and you can never place a larger disk on a smaller one. The puzzle is a great example of recursion, and for us today, an example of how to deal with those use cases. The really tricky part is this method, which is where the recursion occurs. The method is short, it's dense. Now, before we continue, let's talk about recursion. Recursion is not nice code. It may be efficient, but it is not nice. It's hard to model and comprehend, especially in our small brains. With complex calculations and the complex base cases, which is the exit condition for the recursion, the so-called edge cases are not in the shadows. They are hiding in plain sight. Maybe our genie will have better luck. Oh genie, please generate test cases for us. Okay, let's look at the result. There's nothing wrong with this list. It checks the algorithm in different ways. And the third one is checking the efficiency of the algorithm may need some more details as to what we're actually testing here. But otherwise, generate these tests and ship it. Not so fast. I need to step in and see what we really got here. As the human in the loop, I won't blindly accept the list. I need to review it. I need to go over the list of the tests and says, yes, these are the essential tests that I need. And I need to use my judgment to say, well, these are more important than others, and these are what I'm going to write. Note that the suggestions for the tests are really unit tests, but they're testing the function as a black box. They check the algorithm from input to output. This is really usually okay for unit tests, but with recursion, it's a different issue. What if we want to check the incremental steps and how they are working? While the first three suggestions will give me confidence that the algorithm works as a whole, I need more tests that will give me confidence that the intermediary steps will work as I expect. And what about the base case, the exit condition? It seems like our AI assistant forgot it can read the code. So, by using AI as a brainstorming partner, we can go beyond simple does it work testing. We start building confidence from the deepest levels of our code. With unit tests, we catch potential issues before they get into production. Unit testing is about getting the confidence and feedback that our code really works as we expect it to. When we use AI to come up with cases, we'll eventually have more cases and more confidence. But we need to make sure that these are the tests that we want, and if there aren't any missing. Thanks for watching. If you like this video, like, subscribe, share it, and watch other videos on this channel. And in the comments down below, tell me, do you generate tests with AI? Are you satisfied with the result? Until next time, bye-bye.